have done 300 plus videos on GK tricks, and in future I am going to upload more and more videos of GK, aptitude, reasoning and in English. Friends, I will cover complete course for free of cost. So please encourage me by subscribing to my channel. Friends, here you can see the subscription button. Exactly down the video you can see the subscribe button. Here you can see the subscribe button, friends. If you subscribe to my channel, you will get updates of my upcoming tricks. So please don't forget to subscribe. And friends, in the exactly down the video, here you can see the description. In the description itself, you can see the links of my previous videos, topic wise. Here you can see all the links of my previous videos. And friends, if you want to follow my tricks in Facebook and WhatsApp, here you can see the links in the description. Here you can see the links. Here you can see the links, friends. So please go through the links and you can subscribe to my Facebook or WhatsApp, and don't forget to subscribe. If you subscribe, you will get updates of my videos. And friends, please don't forget to share my videos. Thank you.
And today we are going to discuss about an aptitude topic, and coming to this topic, it plays a very important role in most of the banking exams. I cannot see a question paper without this topic's question, and this topic has a wide range of question types. I can simply ask a very basic questions, or else I can ask a level 2 questions or level 3 questions. I can frame any kind of question which actually I need, and this topic has a very wide range of sections also, because it is like I can ask questions basis on simple work and time related thing, or else I can ask questions on the number of men working, number of women working and the efficiency, or else I can simply ask questions on basis of number of days they actually work. So this topic is time and work. So you might have guessed the topic from the introduction I gave to this one. So we are just going to discuss about the basics of this topic right now, and to solve this kind of questions coming under this topic, we actually use a lot of methods. We actually have a fractional method, and we have a LCM method, and we have a method called as chocolate methods, and we can use a lot of methods to solve this topic. And right now we are just going to discuss which methods is very efficient and which is very time consumption, and which methods is very strong when compared to all the given problems. And basically, before going into the topic, I just have to check whether this topic has a meaning. How does time and work will vary to each other? How does time and work is getting related to each other? If time increases, what happens to work? Any clue? So now I'm just going to compare the two factors, time and work, and right from now you can think very practically, because this is a very practical application topic. So you just think I have some 10 works to do. I have some 10 works to do, and I can complete all the 10 works in one day. Got it? I have 10 works to do, and I can complete all the 10 works in one given day. And if suppose my work is getting increases to, say for example, 20, what happens to time? What happens to time in a very practical manner? In one day I can do 10 work, and if suppose I have 20 works, how many days I will take here? You got the answer. So this number of X days should be like, it can be like higher than one day or lesser than one day, or it can be of what cases? Good, it must be like higher than one day. Got it? And you just think what's practically happening here. What's happening to work here? My work is getting increases. Good. My work is getting increases, and if my work increases, what happens to time generally? Time also will get increased. Good. And here the scenario is happening like my work is getting increases from 10 to 20, and time taken by me to complete that kind of works again taken from one day to some other higher than one day. Got it? So when works generally increases, time also will get increases. So on what proportion are they in? They will be in direct proportion, and this is the very first point you just have to keep in mind, always coming for this topic. Got it? So when work increases, time also will get increases. So I can simply say that work and time are directly proportional to each other. Got it? When work increases, time will also get increases, and again on the vice versa, when time increases, work also will get increases. Got it? Say for example, like I have one day, I can do 10 work. If suppose I have 3 days, how many work I can do here? 30 works. Simple. So if time also increases, work also will get increases. On the other pattern, what if my work is getting decreases? If I have 10 work to do, I can do it in one day, and right now I have only 8 work to do. Got it? Right now I have only 8 work to do, and how many number of days, X days, I will take to complete the 8 work? And that's my question. And again, you just compare in a very practical manner, because as I told before, this is a very practical application topic. So here what's happening to work? The work is getting decreases. It is getting decreases from 10 to 8. Got it? And when work increases, what happens to time in a very practical manner? Time also will get decreases. That's good. So the x value should be very less than 1 day. So the time also will get decreases. Got it? So if work increases, time increases, direct proportion. And again, if my work quantity is getting reduced, again time also will get reduced. So whatever the effect in work is there, it affects the time also in the same proper. If work is increases, time increases. Work decreases, it also will get decreases. So what all changes happening in work, it affects time in the same proportion. And again, coming to the very main point, it's like how can I find x value? If suppose I have 5 over here, I can simply say it as half day. But here I have 8 days. 8 work, sorry. So how can I find x value? For finding x value, I should do either two cases. I can simply go for a cross multiplication, or else I can go for a straight multiplication. Out of these two, which is a very appropriate one to find the answer? I should do cross or straight multiplication. Please remember this very important point. If any two objects are in direct proportion, when they vary in a very direct proportion, I should always go on doing the cross multiplication to get the answer. And if suppose you are going for straight multiplication, you won't get the answer for whatever the case may be. Got it? So here I can simply find the x value as 10 into x equal to 8 into 1. So x equal to 8 by 10. So this could be my answer for the given number of questions. Simple. I can again go for a factorization of this one. So this simply becomes 4 by 5 of the days. So I will just take 4 by 5 days to complete the remaining part of work. Got it? So when it is direct proportion, always go for a cross multiplication, and that's what you just have to do for this topic as a whole of this topic. And the second very important point is, let's always start from the basics. The basics of these topics always have a question like man, day and work. Got it? So what's maybe man, day and work, or woman, day and work, or boy, day and work, any number of persons, and this topic has a question like, I'm just saying an example of a question. I'm just having a scenario like there are 10 men. Got it? It can be 10 men or 10 boys or 10 women or 10 girls, anybody. It's just 10 members of there. 10 persons is working for some 5 days. It can be 5 days, 5 weeks, 5 months, any number. Got it? It's just the quantity is like the number of days they actually work. 10 men working for 5 days and again working for some hours, like they work 2 hours per day. Got it? They are working for 2 hours per day, and they can build a building, they can build a wall which is 100 meter in length. This is my first case. Got it? I'm just saying that 10 men, they are working for 5 complete days, and they work only for 2 hours a day, can build a wall of 100 meter length. Now the second scenario is like, if the same work, got it? If the same work, if building the same 100 meter of work is done by some lesser number of people. For example, let's take only 8 men are working now. So only 8 men or women or boys are working now, and again if 8 men are working on the same project, got it? And they work for some 3 days, but they work for 5 hours a day. Got it? If they work in this case, what might be the length of the wall? And this is my question. Got it? 10 men working for 5 days, working for 2 hours can build 100 meter, and 8 men 3 days, 5 hours, what's the length of the building? This might be like very simplest question I can ask in this topic, and for solving this one, I just have to take this concept, and I will use this concept, and I simply go for this formula. I can take it as number of men into men or women or boys or girls into the days they've actually worked. So man, day, number of days they work, again what's the hour they have taken. So man into day into hour divided by work. This is for this first set of people, and for again second set of people I can go for the same concept. This is always equal to again number of men in the second case into days into hours divided by work. This is a very simple formula I can frame from the part of the proportion of time and work, and I can simply solve the answer. And here I can simply take number of men is here 10 men, so go for 10 into, and days is 5 days, 5 into 2 divided by 100 meter, 2 hours, and work for 100 meter. This equal to number of new men is 8 men, and number of new days is 3 days, again hours is 5 hours a day. They can build x meter of length. So I can simply multiply them and cross multiplication can be done and I can get the x value in a very stated manner. I can find the answer of x. That's it. So this plays a very important role when the question is being asked on the man, number of days and hours, and in terms of length or in terms of work. That's it. And this work can be building length of the it can be like length of the building, or it can be like some other work. Got it? So you just have to do only this thing. You just have the formula in mind. Man, day, hour divided by work will be always equal to man, day, hour divided by work.
Friends, subscribe to watch upcoming tricks of very important GK topics. Around 200 videos I am going to upload in future. So friends, get subscribed to get updates of my upcoming videos. If you subscribe, you will get the updates of my upcoming videos. Friends, here you can see the subscription link. Click this box and get subscribed to my channel. If you subscribe, you can get updates of all my upcoming videos, and follow my tricks on Facebook, WhatsApp and Telegram. You can see all these links below in description. Friends, see in description for complete list of videos topic wise. Till now I uploaded 300 videos. You can see all the videos links and the topic wise below in description. Friends, thank you. Please share my videos and don't forget to like and subscribe. If you subscribe, you can get updates of all my upcoming videos. Thank you. Have a nice day.
And we have just seen the basics of time and work topic in the previous sessions, and here I am just going to discuss some of the other important sections coming into the topic time and work. And we saw man, day, work basis concept and what's the variation between the time and work in the previous video, and this video we're just going to solve about the real time questions coming into this topic. So let us go for a very small basic questions. So I'm just saying that there's a person A, and A can do a work in some 10 days. It is simply given that the person A can do a work in 10 days and person B can do the same work in 20 days. And my first question goes like, what if they actually do the work in a combined manner? So what if they work together? So first part going for work together. I can take it as A plus B. And this is given scenario. It states that the person A can do the work in 10 days. This is for when A alone do the work, and this person B is doing the same work for 20 days, and again this is for person B, again alone working for the given work. And my question is simple: when those two persons A and B work together, how much days they will take to complete the given work? So this is a very basic criteria for the topic time and work, and how can we solve this is my question. And again we can go for two methods. One is like we can solve in terms of fraction, and second we can solve in terms of LCM method. But when we go for fraction methods cannot be used for all the given questions. Time and work have a very wide range of questions as we discussed in the previous sessions, but the fraction method doesn't stand for all the questions. But this method, LCM method, it's very potential and very important one of the method of this topic, and it stands straight for all the questions. It's like we can solve all the questions with this method called as LCM method, and we're just going to see only that method as of now. So LCM method. And when we come for LCM method, there are only 3 basic steps. Within 3 steps I can get the answer. First step is like take LCM. And we should take LCM for the number of days. Got the point? The very first step is like take LCM, and taking LCM for the number of days is the very important step. This could be my first step. And second step, finding the per day work. And per day work means that per is like per out of 1 day. So per day work just states that in 1 day how much work actually they are yet to do. It means like per day work. Got it? In 1 day how many work they actually do single, alone or together. That comes on this category of per day work. And third, the solution directly. Simple. Using this only 3 steps I can solve all the questions coming into the topic time and work. Just 3 steps, just apply this one and you will get the third step as the answer directly. And now we are just going to see how we are just going to apply this 3 steps for the given question. And take LCM. Take LCM means that we just have to take LCM for the given number of days. And here the value is 10 and 20. 10 is the first number of days and 20 is the second number of days. So simply take LCM for these 2 numbers. So 10 comma 20. When you go for LCM, I can take 2 as common, it becomes 5 comma 10. Again I can take 5 as common, it becomes 1 comma 2. Again take 2 as common, 1 comma 1. So LCM we generally do until we get the last answer as 1 comma 1. So here the LCM value is LCM equal to, it's like 10, 20 and the unit of LCM. And how we just going to express LCM? We just going to express it in terms of number of parts. Good. So LCM equal to 20. I can simply take this 20 as 20 parts. Got it? And this unit is very important while solving the question. The word called as parts. You know, this 20 parts means that this I can consider as a total work to be done. And the meaning of the word parts is simply like a sequence or segments of work. And here I can interpret this as I have 20 parts of work to do as together. This 20 becomes the least common multiple of these 2 persons. So it simply means that 20 units of works are there, or 20 parts or 20 segments, you can mean whatever you want actually. So 20 units of works are there commonly for these 2 persons. And second point, we just have to find the per day work. Got it? Per day work means that in one day how many work actually they do. So to find the per day work, you just simply go for A value. So when coming for A, so what's the total work here? Total work is this 20. Got it? So the common work is 20 here. So simply take 20. And when this 20 work is done by person A, how many days is actually taking? A is taking 10 days, right? So this is my total part of work, and when total part of work is done by person A, he is taking only 10 days. So simply divide it by 10. This is equal to 2 parts per day. That's it. And this means that per day work. Or else we can take this 1 day work. Got it? So A can do 2 parts in 1 day. This means that when A is working alone, he can finish only 2 units or 2 parts in a one particular day. And what about 2 days? If he can finish 2 parts in 1 day, in 2 days he can finish 4 parts. Again in 3 days, 8. It goes on as it is. Got it? Again go for the person B. Again same scenario happens. You just take the LCM value 20 and divide it by the B's values here 20 by 20. And B can do 1 part in 1 day. B's value is 1 part in 1 day. Got it? So this means that 20, I can take this 20 as a total work. Always keep in mind that 20, the value we have found as LCM, it serves as a total part of work. So total work is 20, and when 20 they are done by person A, it becomes 2 parts per day. Again 20 by 20 becomes 1 parts per day. So when A can work separately, he can do 2 parts in 1 day. Again when B works separately, he can do only 1 parts in 1 day. Okay, now go for the question. The third step is solution. Okay, now going for the question. The question is based on working together. This means that when 2 persons A and B work together, they put both of the efficiency in that single particular work. How many days will it take? That's my question. Got it? So when A works separately, it is 2 parts. When B works separately, it's only 1 part. So what if A plus B work together? Very good. If A plus B work together, I can simply add these 2 numbers. That's it. 2 is for A and 1 is for B. So A plus B equal to 3 parts per day. So 3 parts per day. Got it? So A, B can together do 3 parts in 1 day. Got it? But here again, what's the total number of works? Here I have 20 works to be done. So simply go for when A and B work together, they can actually complete 3 parts in 1 day. But here the total work is 20. So 20 divided by 3. Again go for the same scenario. 20 divided by 3. That's it. So this becomes 6 and I have remainder as 2. So 6 2 by 3 is my exact days in terms of fraction. And I should not say the days in terms of point. Please try to avoid the point numbers, as point numbers are always an approximate answer and point doesn't form as a regular number for representing the number of days. Got it? So whenever in aptitude, when you solve the time and work topic and when you solve the time, speed and distance topic, always go for a fraction number. Please don't give importance for the decimal number. Got it? If it is not getting divided, you just take the remainder in the numerator one and divide it in the denominator one. So I can represent as mixed fraction. So answer is 6 2 by days. When A and B work together, they take 6 2 by 3 days to complete the full work. Got it? I can either find answer in this format or else I have one more method. Instead of doing this, because this is not applicable for all the questions, instead of doing this, We have just seen the variation topic, right? We have just seen the what in how much thing the time and will get vary, right? I can again compare them. Again take work and time, or time and work both is sufficient. Take work and time and just compare the last part. Here I have 20 parts of work and 3 is my efficiency. Got it? So when A and B work together, they can complete 3 parts, means 3 units in one day. I am just going to compare the work and time here. I can take 3 parts as the work done because it's 3 units or 3 chocolates, anything, and per here it is 1, simple 1 day. Got it? So when A and B work together, they can do 3 parts in 1 day. Got it? But here I just have to go until 20 parts. So it is X, simple. Can you able to relate the basic thing with the question here? Exactly. I'm just going to compare the work and time here. Got it? So A and B can work together. If they work together, they can do 3 units in 1 day or 3 parts in 1 day. But here the total work is 20 parts. So for completing 20 parts, how many days they actually take? It's my X value. And again, work and time always in a direct proportion. So do cross multiplication to get the answer. X equal to same answer is 6 2 by 3. Either we can go like this method. Either we can go like this one, taking the variation concept, or else I can simply go for 20 by 3 equal to 6 2 by 3. Both will lead the same answer, but this is applicable for all the questions, whereas this is only for certain point of the questions. Is it clear for you guys? Okay. And now we can go for the second part of the question. It was like a second section coming into this topic, time and work. And first we have solved in the previous sessions. It's like working together, A plus B working together. And second section is like if some of the persons leave the job, or else if some of the persons is joining the job. It's simply like any one of the persons getting included or excluded. So second concept will come under the included or excluded thing. And this exactly covers all the questions coming under if a person A is getting away of the job, is just leaving the job, or else a person called C is joining the job. If I have got that kind of questions, it will come under the topic called as included or excluded type. Got it? And we can go for the same question. A is 10 days, B is 20 days. It's just for your understanding, and I can use the same method LCM to get the answer for this question also. But here the questions stand like this. Here the question says that actually A and B start their work together. Got it? A and B actually start their work together, but they work only for 2 days. My first point. And after 2 days, it's like after 2 days, A actually leaves the job. A actually leaves the job. And if B alone do the job, how many days he will take? That's my question. So B alone is like question mark. Can you able to get my question? The question states that A can work in 10 days, B in 20 days. Got it? And A, B actually work together. They can do the work in 2 days. They actually doing the work only for 2 days. After the span of 2 days, A is actually leaving the job, and remaining work is done by B alone, because actually A is not here right now. Got it? So B alone do the job. Do the job. If B is alone doing the job, how many days he will take to complete the full job? That's my question asked in this scenario, in this part 2. And this has A is leaving the job, right? So when some person leaves the job, I should take this category. I should try the part 2 kind of thing. And again, don't worry, the same thing we just going to do in this question also. And first step, what's the first step to do in this LCM method, time and topic? Taking LCM. That's good. So here the LCM value we actually took it in the last problem, the same numbers. So it is 20, and I told you LCM should be always considered in terms of parts or units. So this is 20 parts. So LCM is 20 parts. And what's the second step? What's the second steps to be done in this LCM method for all the sums? Finding the 1 day work. That's good. So here 1 day work of A is simply again the same thing. Go for 20 divided by A's part is 10. So A can do 2 parts per day. If A work alone together, then he can do only 2 parts in 1 day. And again for B, it is again the same 20 by 20. It is 1 parts per day. If B alone work together, he can do 1 part in 1 day. And again, what if A plus B work together? A is for 2 parts, B is for 1 part. If A plus B work together, I can simply add them. It becomes 3 parts per day. And this becomes the same step, same procedure for this sums also. But after finding the LCM, and after finding the 1 day work, you just give a stop over there and please go through the question very carefully. And you just go through the question and please understand what's the story given in the question. Here the question simply states that after actually A and B start working together. They actually start work together, but after 2 days, person A is leaving and B is alone continuing the same job. And if it is so, how many days B alone will take is my question. Got it? And here it is given that A and B work for 2 days, right? Got it. If A and B is working for 1 day, they can complete only 3 parts per day. So this is efficiency of A and B. So if it is like, if A and B work for 1 day, they can do 3 parts. Is it so? If they work for 2 days, how many parts they can complete? The same statement I'm repeating here. If A and B work together, they can complete 3 parts in 1 day. 1 day, 3 parts. If it's 2 days, how many parts they can do? Very good, 6 parts. So actually A and B work together and they can complete 6 parts altogether. Got my point? It's given, we found that 1 day 3 parts and it's 2 days it is, so into 2 it's 6 parts, it's over. So 6 parts of work is been completed, and again please put a stop mark there and find what's the remaining part of work. And this is very important for the included and excluded format. If some questions comes under this topic, this particular part, you just have to find the remaining part of work, and this plays a very vital role for getting the next answer. Got it? And remaining part is nothing but what? The leftover part. It's very simple. A and B already worked together and they completed 6 parts. So it is simply like out of 20, my total parts, out of 20, 6 is been completed. So what's the remaining part of work? That's good. It's simply 20 minus 16, it is 14. So remaining 14 parts of work is as it is like untouched work. It's been yet to be completed. Got my point? So if they asking anything like inclusive or exclusive, you just have to find one more step called as the remaining part. The same step, nothing to worry. First step is taking LCM, second step is finding the number of days, and third step solution. But before going for a solution, you just go through the question, and if it is like included or excluded, you just have to find one more thing called as remaining part of work. And this is nothing but the part of work which is left on as it is. Got it? And here it is 20 works. Out of this 20, 6 is been already completed. So remaining work will be like 20 minus 16 is 14 works. Again, this 14 works is done by which person? Who is actually doing this 14 parts of work? Question. B alone does the remaining part of work. Got it? And again, what's B's efficiency? If B alone is doing this work, how many days he might take? Come for this one. Again, B's efficiency is 1 part in 1 day. Got it? So again, we can go like 14 divided by 1. So answer is 14 days. So B actually needs 14 more days to complete the remaining part of work. That's the answer. Able to follow me? After finding the remaining work, you just consider who is actually doing the remaining work. Remaining work is done by person B alone. Got it? If B alone does the work, he takes only 1 part in 1 day. This is B's efficiency actually. So for completing 14 parts, he takes 14 days. Again, I can go like 2 methods. One is like I can simply divide them directly, or else what can be done? I can take variation. That's nice. So I can compare the work and time. So B's efficiency is 1 part in 1 day. So 1 unit, 1 part in 1 day. That's B's efficiency. And here what's the remaining part of work is yet to done. He has to complete 14 parts of work. For 14 parts of work, how many days? X days is needed. So again, work and time are directly proportional. So do cross multiplication. So X equal to 14 days. This is my answer. And this comes under the topic, the part called as included or excluded. And please have it in mind, when I have the part of inclusive or exclusive, I just have to find one more, I just have to do one more step, that is finding the remaining part of work is like very mandatory. So please remember, when you face questions like this one, you just have to find one more segment is called as a remaining part of work. Remaining part you just have to complete to find the next step. And this remaining part stays actually like a shortcut, or this stays actually like a launching pad for getting the next step. This stays like a hint for getting the next step for the same question. Able to follow me? Good. And now we can move to the third part of the question. Third part we will generally get like working on alternate days. Got it? Again, what's mean by alternate days? What's mean by alternate days? I'm going for same question. A 10 days, B in 20 days, and if it is so, A and B work together. They actually work together, but they work for alternate days alone. If this is so, what can be the answer? How can I solve it? Again the same step. Take LCM. LCM is 20 and the unit of this 20 is parts or units. So 20 parts is my total work to be done, and finds A's 1 day's work is 20 divided by 10. It is very good. It's 1 parts per day. Sorry, it's 2 parts per day. And B is 20 divided by 20. It is 1 parts per day. And now come to the question. The question is given like they work for alternate days, and the meaning of the word alternate is like the on alternate basis they actually work together. Got it? So this states that, for example, they work for alternate days, and keep like A is the person who actually starts the work. Got it? This has a meaning that on the first day, who will actually start the work? They work on alternate days means that they actually work on alternate basis, like shift basis or something like that. So on the first day, who will actually work? I can take A as working. On the first day, A alone will work. B won't work actually. B actually doesn't comes for the first day. Again, on the first day end, how much of A has been completed? If A work alone, he can do only 2 parts in one day, right? So A is working for the first day, he can do only 2 parts. Got it? On the second day, actually whom will work on the second day? B. That's nice. If again B is working alone, how many parts he can complete? 1 part. 1 part. That's it. Again on third day, who will work on third day? A. Again, if A work on third day, how many parts he will get completed? Again 2. On fourth day, again B, 1. Fifth day, again A, 2. It goes on as it is. So this is a working method for alternate days. It goes on until the works get completed. Able to follow me? Alternate days means that they actually work on the shift basis for each day. So first day, person A alone will work. Again second day, B alone will work. Again third day, A, fourth day, B, it goes on as it is. Got it? Again the work done by A person is 2 parts per day. 2 parts will be completed in one day. Again 1 part completed in second day. Again 2 parts in third day, it goes on as it is. So we simply can take a span of 2 days. That's a thing to be done for alternate days. So just take a span of 2 days. In a span of 2 days, how many work they will get completed? In a span of 2 days, the work done is 3 parts of work. Again for the next 2 days, 3 and 4, again 3. Again for next 2 days, it goes on as 3. So you just have to find the common number of works getting completed. So for the after getting that one, I can again go for the variation time. Got it? Again I can compare the work and time here. Got it? And here the scenario is like when for the first 2 days A and B is working separately on alternate basis, they can do 3 parts of day. Got it? So 3 parts of work is completed in how many days? In 2 days. In 2 days span, 3 parts is being over. Again here, what's the complete part of work to be done? Total part is 20 work, and if I have to complete 20 works on the same basis, how many days are required? It is X. Again put cross, that's an answer. That if it is alternate days, I just have to take a span of 2 days or 3 days based on the question. Simple. So if it is 2 days, the work completed is 3 parts. So again go for this one. Got it? So here 3 parts in 2 days. So 20 parts in how many days? It is X here. Again to cross multiplication. So I will get 3x equal to 40. So X equal to 40 by 3. So if 40 by 3, what's the answer then? I can simply go for a fraction or a proper fraction or improper fraction to get the exact number answer. That's it. Got it? So when I divide this one, I get 1 and 3 and 3, 1 here, again 3. Again please don't go for any point numbers. The remainder is 1 here actually. So simply go for 13, 1 by 3, and this could be my exact answer in terms of number of days. And please try to avoid the point numbers. And these are the most frequently asked questions in the topic time and work.